Okay, I've turned the volume up and the mute button off, and I'm going to try to make another video. This video will be a proof of how timing works in a DCF model. The file, if you want to work along, that will be in edbodmer.com. I'll put it in this proof of concepts in DCF. I don't quite know what else I'm going to put on that page at this moment. And here's what we're going to do. We're going to demonstrate that DCF can be computed with NPV function, the simple NPV function, and an adjustment for 1 plus the whack raised to the 0.5 for half-year assumption. Okay, and in order to do that, now I will use a lot of switches. Okay, and I will make a 300-year model. So here's what we're going to do. We're going to put some assumptions here first. Now we don't need to put all of our details in, but we'll put a short-term growth rate and a long-term growth rate. Oops. Okay. And then we'll put a valuation period, terminal period. You know, why don't, no, okay. We'll yeah, let's make this 2016 and 2021. How's that? And we'll put initial free cash flow to fund. My friend Dennis uses that terminology. Okay. Shift Control 1 to format it. And then from this, we're going to put, and finally, let's put periodic timing of cash flows. And 0.5 is middle of year. Okay, I'll hopefully finish this example fairly quickly. Now I have this on add-ins. I have another file, Control Tab. I have another file named depreciation functions open, and in that depreciation functions I made some shortcut keys. Where's our file? So if I press Shift Control C, that will color the assumptions. Okay, and I don't show the bottom of the sheet. What happens if I go down like this? I wonder what happens on the video if I do that. Okay, now we'll make our model. Okay, oops. Oh, it's a French. Now to start the model, let's put some timing. And why don't we start our model in, how about 2014? And I'm just going to add one, Shift Control Right Arrow, Control R, and then we're going to go to 3014. How about we'll go to 4014, I think. I'm sorry, 2000, 2000, here's 2,314. Is that all right? I think that's enough. Shift control right arrow delete, shift alternate right arrow 1. Okay, you should be able to, hopefully you can do that in a faster period than me now. The key for some of this is just to make some switches. Let's make and now before we make the switches, why don't we look at what we'll do. We'll have 3 cases. Okay, case 1 is the theoretically the true value. That's what we're going to put over here. And then case 2 will be no timing adjustment. And then we'll put, oops, that's case 2. And case 3 will be the corrected case with 1 plus whack raised to the 0.5 power. Okay, we're going to demonstrate that case 3 is the correct case. Of course, I forgot to put the whack here. And how about 10%? And then we'll get this. So for our timing, we first have our year. Oops. Why don't I put a timing section? And then, you know, this will eventually be at the top of the sheet. And then we can, let's put a terminal period. Because it's so easy to make the terminal period, that simply we just put an equal sign and find when our timeline is equal to our terminal period. Now, the second one we can put in is, how about evaluation explicit period. Okay, and this will be and function. This number has to be greater than or equal to the evaluation period, and this number has to be less than or equal to the terminal period. Okay, and if you're a little fancy, we can put a counter. Yep. And then put, so we have 6 explicit periods, of course 1 terminal period. Now, it's going to really help a lot if we, to make our theoretical model, if we put evaluation period, which will encompass everything. Simply, this number has to be greater than or equal to the 2016, so we'll just keep adding that. So that gives us only 299 evaluation periods. And then let's put a short, we've got the, let's put a short-term growth period. Now let's just assume, this is half really for the assumptions, let's assume whenever this is less than or equal to our terminal period, we've got a short-term period, and then we'll have a long-term growth period. And that's simply whenever this thing is greater than the terminal period. Okay, here, that's our big investment. That's our investment in the Control D. That's our investment in this. Now, it happens that for the add-ins, I put a shortcut for the true switch and false switch because I use these so much. Shift Control T. Of course, you can watch another video. My dog's quiet right now. You can watch a video and you can see how to just include these simple user-defined shortcuts in your own analysis. Now, once we have the timing, let's put the theoretically true value. And to get that, let's put the growth rate in first. Okay, and the growth rate simply is going to be, when it's a short-term period, we'll multiply that by the short-term growth rate. Oh, I didn't put a short-term growth rate in. Let's put 20% for the short-term growth rate and 3% for the long-term growth rate. You know, if you do the shortcut with this one, you can do the same thing. So the growth rate is the short-term switch multiplied by the short-term growth rate F4 plus the, whoops, of course I did it wrong. The short-term growth rate multiplied by the short-term growth, the high growth, plus the long-term period switch multiplied by the long-term growth rate, okay? And shift, you know, what do we have here? Do we have another one for decimals? If decimals are 2 points. Okay, and so now we'll put in the cash flow. This is our true cash flow that occurs forever. You know, I suppose I should have really discussed the whole business of a corporate model, which is supposed to be a model that corporation, this is the whole you know, you need to get a little bit, but getting a bit philosophical about this whole thing. We're trying to model an entity that never dies. No such thing. But we're trying to model an indefinite period. This is the whole problem. This is the reason terminal value is such a big problem. Now, here's a little trick. If we want to only take our cash flow over our valuation period, this is why, you know, I think using this NPV function, it seems so old-fashioned, because it always assumes the end of the year. This is why it's so helpful. If we just put if it's the, oops, did we do a total? Yes, we did a valuation period. If it's the valuation period, let's take the cash flow. Otherwise, do nothing. Leave it as false. False is such a valuable thing here, because then we're going to present value just until the beginning of 2016. Now, if we just now take the NPV of the cash flows, this is the NPV at end of year. Okay, we can just put equal NPV at the whack of all of this. Okay, that's just really an introduction to this whole thing. Alright, now, but now let's compute the NPV in the middle of the year. So to get the NPV in the middle of the year, we can put a PV factor. Now, again, this is where the switches can come in. We take this number, multiply it by 1 plus the whack, okay, and but we only take it times the 1 plus the whack when we when we have a valuation period. Okay, so we can just continue that all the way. Now, if we would take a NPV check, here's all you can do to get that calculation. You can make a sum product, and when you make the sum product, take the simply take the cash flow and divide that by the discount factor. Okay. I just made a little mistake here. This should have been the sum product, cheated by the way, of this number divided with the true false things divided by this. All this does is demonstrate you can do the same thing with the sum product. Now, here's what we should have really done is let's put a counter. Excuse me, let's not do it here. Let's put a counter. And now we're going to make the calculation with a half-year assumption. Now, the thing you really need to understand is that the reason you make a half-year assumption is because we get cash flows in our annual model fiction. We really need a day-by-day, hour-by-hour model. And if we make a model that we don't receive these cash flows all the way at the end of the year. Okay, so we can make a counter, which is the same sort of thing, really, as the if it's the valuation period, then we'll take this plus 1. Otherwise, we'll just take that one. So all we're doing is making the model really flexible, again, using the true and false switches to make a very flexible counter. And then once we have that counter, then we can put a adjusted for half year. Oops. Now, when we do this one, all we'll do is what we want to do this. What we want to have here is instead of I just should have started with 0, shouldn't it? Instead of this being 1, it should be 0.5, and this should be 1.5. So we simply take this number. But if it's the if it's the valuation period, then we'll take this one minus 0.5. Otherwise, we would do anything. Okay, and then we can now. This, of course, only works if we have a constant weighted average cost of capital. We'll adjust this whole thing for changing cost of capital a little bit later, and then unfortunately I see some of the simplistic formulas won't work, but then we'll put a PV factor with 1/2 year. Okay, and that PV factor with 1/2 year is simply 1 divided by 1 plus the WACC raised to this number we just computed. Okay, so when we make our theoretical value with half year, okay, that's again shift control 1. This is sum product tab, of course. This one, and this time, since we like the other way, we multiply by this, so we get an increasing value, and we can let's check this with XNPV. You know, some people are, true believers in all the NPV formulas. this is a little bit tricky. What we want to do here is make a date of cash flow. So our date of cash flow in this case would be when, if it's the valuation period, if it's the valuation period, then we're going to take the date of this one, and let's make it 7/1. Control R, but Shift Control 3 gives you the date. So this gives you July 1, actually. I think the middle of the year might be actually July 2, but I think this is close enough. And then if it's not this one, we'll put a date. We'll just bring it back to the first one. So we'll take a year and then 1/1. Oops. Why? Oops. Okay. It's a little lazy. Shift Control 3. What happened there? Okay, let's, excuse me, Shift Control right arrow. Let's just make this a little bit wider. Okay, so here's what we have. We have a date that is 1 July, and actually this cash flow occurs in 1 July, but otherwise we're going to make that year. Oops. So this is kind of silly a little bit, but so we'll bring it back. This will always bring our cash flows back to 2016. So if we take now we take the XNPV and we just use the whack, and then we put our cash flows in. I don't know if the cash flows will be the shoot, we needed a initial, excuse me for that. Okay, if we take this cash flow and we multiply, and take this cash flow and multiply by 1, then we can just switch that cost off. Okay, and then we can put XNPV and take our whack, take the cash flows, and take the dates. It gave us a very slight, well, I'm not going to worry about that slight difference. Okay, so that's the half year assumption, and then we can also apply the adjustment to EOY. All we could do, we could take our end of year, multiply that by 1 plus the weighted average cost of capital, and raise that to the 0.5 power. And then we get exactly the same result as we got up here. Oops, I just didn't show you this. This was 1 plus the whack raised to the E16 is the 0.5 power. Okay, I don't like range names, so I'm not putting that in. You could make a very good argument that it would be nice to have a range name in that one to see really what you're doing, but I'm not going to do that right now. So that's our theoretically true value. Now, let's try the kind of application of terminal value. Now what we would do here is we would get explicit cash flow value, which I'm going to do fairly quickly, but if we simply take an if statement, not a multiplication, an if statement, take the explicit period and go up to the true cash flow, that gives us a false. So that's the same sort of idea. Now, if we would like to get the NPV of this, we can put NPV. Whoops, why did it go down there? We put NPV at the whack of all of the cash flows. Okay, let me see the euros. Get rid of it. Okay, so that's the explicit cash flow value output EOY. We didn't make any half year adjustments. Now we'll make a terminal value. And for our terminal value, here's where I used to get so confused. I said, well, the terminal value doesn't occur in the middle of the year. It goes at the end of the year. But when the person who's buying the company makes his assessment, he's going to use the middle year cash flows. So it all gets a little bit tricky if you go around and around and around about all these things. So for the terminal value, here's the trick. We first take it if it's not the terminal period, but explicit period. We'll show you that. And if it's the explicit period, then we're going to take our cash flow and multiply that by 1 plus the growth rate and you know, the terminal growth rate. And I can see people saying I should have used a little bit of a range name here for the growth rate and terminal value just to see what it is. And then we multiply this by the terminal switch. There's the terminal period switch. This one, okay? And if we do that, it gives us our false. So the reason I was doing this is to get little zeros in here, and then the falses here, okay? And then we just can take, we can, you know, put a F4 in here, shift down, Control D, and then we get our enterprise value with the end of the year assumption, which is just alternate equal of these two, which is the same as the end of the year assumption up here. So we put this. So this is with no timing adjustments. And then the final thing we'll just do is include a timing adjustment. Which is 1 plus the WAC raised to the 0.5 power. So we simply take, if it's a half year, we could make it some other thing. 1 plus the, suppose if there was some sort of seasonality, we could somehow adjust that 0.5 and get all theoretical about it. So here's our correct value. Now, the time when this, if we made the, on both three, let's put the percent difference. Okay, and the percent difference is this with the half year. Let's make this one divided by this one. So we get an extra 5%. Now it doesn't really matter. The growth rate, I think, doesn't matter, does it? What really matters? Well, it matters in absolute difference. Okay, so that's going to be this minus that. Okay, the now, so let's, if we had a lower growth rate, we get a lower value and a lower amount. If if we had a 20% whack, then we get a 10% difference, so it's not exactly 10%. If we have a 5% whack, it's only a 2% difference, so it's that magnitude of the difference depends on the whack. If you're in a high inflation environment, it's going to make a whole lot more of a difference. And I think that's enough of this. Goodbye.